now, then we go straight to the commencement of today's session, continuing from where we left off last session. And just by way of reminder, we've been dealing with structured query language for some time now, and we are getting deeper and deeper by the day. So as at the last session, we were able to treat up to the point where we explain what the crucial and important keys, database keys were um, in structured query language. And essentially, we discussed the fact that beyond being able to extract or retrieve information from a particular table, SQL has a more robust functionality than that. So meaning you can extract information not just from a single table in a database, as many tables as possible that are in the database. You can simultaneously retrieve data from them as long as there is a logical connection between those tables just to answer a particular data analytics question. And to establish the connection between those tables, you've got to ensure you have you know how to use primary keys, which are always established more often than not by default while you are creating the table afresh. During table creation afresh, you have the primary key being specified. Sometimes people don't specify it, but it's always good to specify it because when you have the primary key being specified now, it's easier to pick that primary key and connect it to another table. Then that primary key becomes, takes another name entirely, no longer primary. It will now be a secondary key in that particular scenario. So that's how important keys are in connecting different tables in a database and now being able to extract data simultaneously across all of those tables. So we have to know what those primary keys are and what what the foreign keys are. A primary key in table A, if reintroduced to table B, becomes a foreign key in table B. So it is just a logical connection between table A and table B. When the primary key and the foreign key connect, then the two tables are well connected. So you can join the two tables on that particular set of keys specified right there in the query or SQL command. So we'll get to that as we move on today. So ahead of that, so today we'll begin with what we call database relationship. And for database relationship, it is still trying to prepare our minds about the fact that SQL functionalities and usefulness goes beyond just being able to play around the entries in a single table. And we have demonstrated this severally in previous sessions. So you can do well to watch all the recorded sections to catch up. So what actually separates relational database is the power or ability to establish relationship, and the relationship that are possible to be established in relational database are subgrouped or subdivided into three. In this case, they are, it could be one to many, it could be one to one, and it could be many to many. I could recall we did things like this back then in additional mathematics or further mathematics, where we will have one-to-one mapping or one-to-many mapping or many-to-one mapping and what have you. And it also surfaces in matrices in a few advanced mathematics used back in engineering. But that aside, it's just it's just a similar concept to what we are trying to deal with here. So the relationships that are possible between tables in a database, don't forget that particular order. There must be a database before we can have tables. You cannot create table in vacuum. Whatever table you are creating and you successfully create it must have been created on a particular database. So even if you don't know the name of the database, it's already stored in a particular currently active database as at the time you are attempting to create that table. So having had a database named, defined, created, and most times you don't need to do anything extra to create a database, just to have a name in mind and create a database, and SQL goes ahead to create a database for you. We've created a couple of databases at the beginning of SQL. I will refer to it shortly if I have time, because today's session will be a bit fast due to another session coming up in less than 30 minutes time, but we'll rush to see how much we can cover. All right, so one-to-many relationship simply means a single entity or record in a particular table has relationship with more than one record or entity in another table. That is one to many. So meaning that this particular entity, for instance, it could be the name of a student. It has relationship with more than one entity in another table. And in the table we have a table for students, we have a table for teachers, and we have a table for meals. And for instance, a single student in a table called students having a single ID, that single student can have relationship with more than one items in a table called school meals, because we are dealing with school now as a database and we have different tables. One table is talking about students, one table is talking about teachers, one table is talking about the food they eat at lunch. And of course, we have, no singular person can say all he or she eats is just a particular single meal. No, it's not possible. So when you list different meal item in the table called school lunch, the relationship between that table and the table for students will be one to many, because it is more than 100% certain that one student will have likeness for more than one food type. And that is just an example of one to many relationship. So if you now want to define the relationship between table student and table school lunch, the relationship is one to many, and that is just an example. And between I'm beyond one to many, it could also be one to one, meaning before one to one, when you establish a one to many relationship, what it also means is that only one item in table A, for instance, has relationship or connection to many items in table B. But in table B, there is no single item that will have relationship to table A more than one time. So the duplication only exists in table B, not in table A. Those are the conditions. Now, the second type is one-to-many relationship, meaning that a single entry, a single record, a single observation in table A is related or is connected to similarly a single record or item in table B, one to one. That is pretty much straightforward. And the last one is many to many, meaning that there are more than one entries or items or entities in table A that have relationship with more than one entities in table B. So that gives or that makes the connection line to be so wide, because many in A, many in B, and can form as many relationship as possible. So those are the kind of relationship that exists amongst different tables in a particular database. Now, after database relationship, we also have data types. We've touched somewhat on this before too, but we can just quickly brush it up again by way of reminder and a little bit going deeper. So there are different data types, and it is very, very essential to also bear it in mind. When you are creating table, you must equally specify the data type, each of the attributes. You remember what we call attribute. Attribute in this sense is column. Each of the attribute or columns you are creating in the table, you also want to specify the kind of data type that should be entered into those columns. If anybody is imputing any record in that table thereafter and they mistakenly type in a different data type that is already pre-specified for that particular column, the database application will not take it. It will show an error and ensure the person corrects that particular thing before it accepts any entry you want to bring in. And that's what makes our relational database, well structured. That is where the structure concepts in relational database come from. It is well structured and well ordered, such that if you do not follow the specified order, it will not accept anything and nothing can be changed in it. So, and that's why we need to have an idea of what data types are. So we have a type of data, a type of data that we call fixed character. They have fixed length of character. You cannot write beyond that. So it could be a string sometimes, and it could be being a string means it's a combination of letters and numbers, and sometimes it can even have special characters, but it is fixed in that the length cannot go beyond a particular number which is known to the database, and in this case is 255 characters. It cannot go beyond that. However much you want to write, the moment it's going beyond the 255th character, then it won't take the next character. Those are the ones we call we pronounce it as char, but it's actually referring to character size. Now, that is the one that are fixed. Immediately after the fixed character size type of data, we have the variable character type of data. So they are also more like a string. A string, just always when you hear anything string, is a combination of a couple of items in it. More often than not, it is a combination of letters and numbers and possibly special character on the keyboard. So a variable one, as the name indicates, gives more flexibility, unlike the one that is not variable that we spoke about earlier, which is just a character size. But this one is a variable character, and it means it is more flexible, it can be more extended or is extendable more than the other one. And of course, as much as it's extendable, it is still has a maximum length. But it is rare for anybody to even get up to 1/100 of the maximum length. What do you want to be writing that will get up to that? And imagine having written up to 65,000 characters. What will you be writing in a data table? There is no need for story. Just give us the data in numbers and move on. And if you need to write any few things in string, they cannot be as much as this. But for variable character definition's sake, it's just to show that it has more flexibility and more allowance for as much character length to be accommodated as possible. Then we have some that are purely string, purely text, and these are entirely string. No number most of the time is involved. It's just text. And another is ints. The reason all their names are written these ways because those are the ways they are written in SQL code, so that we can begin to get familiar with what they are, with how they are written. That's why I left them this way. So for the int is an abbreviation for integer. So the moment you are trying to create a table and you have written the column name, after writing the column name, you want to specify the kind of data that should be in that column, and you put int, it means that you are saying to SQL that the entries that must be in this column must be integers. And these are numeric and could be positive or they could be negative. We have other ones that are equally decimal, and we have floats. So decimal and floats are a bit close because sometimes we refer to decimal numbers in data science as floats. And of course, maybe for SQL, it could just be slightly different in terms of maybe decimal point and what have you. But they are also talking about numbers beyond all numbers that have some decimal places after them. And we also have the date and time type of data too. There are different formats of writing dates. There are different formats of also writing time, depending. We treated this during our exploration in Excel. Uh, Depending on the region or countries or geographical location, the way year, date, and the way year, month, and day are written in terms of date. For instance, in America, is different from how it is written in England, for instance. So some write year first, followed by month, and followed by day. Some begins with day. For instance, I know in Africa, Nigeria begins with day in that logical ascending order. Day belonging to a particular month, their month falling within a particular year. But in some other climes, they are written differently. Those arrangements are reordered in a way. It doesn't mean they are incorrect or not right. It is just the preference of each region and country. So one has got to understand that this can occur. So if you have already specified the arrangement in the database that your date column must follow this way, any data being imputed, the person must be conscious that, okay, what I'm imputing first must be year before month and before day, and just follow what the specification is. And same goes for time. The hour, minutes, seconds can be rearranged in any way depending on how the specification was originally done, and depending on what region or country we are also talking about. So, a quick demonstration just for us to see some of these data types we are talking about. So we have created in the course of our practice a database, and the database is called, um, okay, you can just tell the SQL to show you databases so you can be sure of database you are in. Yeah, it gives me the list of databases. Then I can say, yes, I have so I can tell it to use school underscore demo, which is the name of one of the database as is listed here. I have school underscore demo here. That's the third to the last right here. So I want to use that database. So I just go there to tell it to do that for me. Then it's getting ready to use school underscore database. How do I know that ran well? Right underneath this window, you see the report of what you have just run up here. And when you have your green here, it means it's run successfully. I don't always bother to read the details so long it is green. But if it is red, I know something is wrong somewhere. So I have to come and read the error message to see what you are expected to pay attention to and correct so that you will be sure the application is running the commands as you are giving it. So I want to check my tables now. I am now in the correct database. So on checking my table, I can just say, remember our select all, from where I have created a table in that database called school underscore demo. The table is named students. So I have it now. I put my semicolon as the last, then I run this. It brings out the table. This is the table for students created in that database. Now, what do I want to show is that in creating table, we could have as much as, we could go as far as making sure we specify our data type. Yeah, that's where I want to quickly demonstrate. So if we successfully demonstrate and we still have a few seconds or minutes, I can show how we can join two queries from two different tables and pull it out straight away. Let me see. So I want to show a data type now. Yeah, so I can say create for me, just like I have done here already. So I can say create. So in creating that, I have to specify a few things, which is important for us to see. See, what I've done here is that I've said create table. In this way, I am creating the table. The name of the table is Muse, just like just like I mentioned in the course of the explanation. Now, I have a table called student. I have a table called teacher in a database called school underscore demo. Now, I want to create extra table for Muse because there are different food students eat during their lunch, what have you. So I want to create a special table entirely. So in my table, the name is meals. In the columns, the table must have meal ID. I have specified. Look at what I wrote. Int. The int here means integer, just like I explained earlier while I was discussing data types. I have said that in this table called meal ID, the data type is int, which is integer. Then I went further to tell it, make sure you make it a primary key because I'll be using it as a primary key. I may likely want to join this primary key with another table and it becomes a foreign key in that particular table such that I can easily pull out data from the two tables simultaneously, because the only way you can pull out data from two tables is when they have something common to both of them, and most of the time it is primary key factor. So primary key in table A being repeated in table B assumes a foreign key nomenclature, and when you quote that in your query inside SQL, it goes ahead to pull out data corresponding to those two primary key and give you that return. So I have specified this one should be integer, then new name is another column. I want it to be a variable character. Can you see just the things we have explained in theory? So I want to put it in practice now. New type, then price. Okay, I have chosen that. Okay, the data type will be decimal. Don't forget, we also have a decimal data type. Then the new date, the data type is going to be date. Then I come down just to close it and put semicolon. I will just select all of this guy this way. Then I run it. Yep, it has run it for me. And I can see right here, it says mutable integer primary key auto increment. I set the primary key to auto increment such that when I'm imputing data inside that table, it will give me something. To be increasing the primary key ID number in ascending order automatically. So the table is already created now. So how do I know? I can just say show tables, show tables. You can see now it's showing tables. I have teachers, I have students, I have another table called shapes in one of the exercises we did. Then the table I just created now is meals. Can you see? It's already among the table. This is the name of the table right here. Create table called meals right here. So it's already showing me the table has been enlisted there. So what do I do now? I want to go ahead to quickly put a few entries in the table very fast so that I can just see the table pull out some few things. Don't forget we have named or specify what the column name for the table should be. So I have this, then I'm telling it to go ahead, um, insert into a table called meals, go ahead into the column called meal name, meal type, price, and meal date. Here I have omitted the meal ID, which is the primary key because it is already set to auto. So it will populate it by itself. So most of the time we don't repeat it right here. And I've mentioned the name of the food, blah blah blah, and all that. If I run this SQL command this way, it's going to impute it on that table I have created, which is already done now. Meals already imputed, launch this and that. Okay, how do I see it now? I can now say go ahead and select everything from a table called meals this way. I put my semicolon, I like this, run the code, it will bring that table for me. Can you see? Just now, I created a table and I have populated the table with just a few entries. and it follows the order in which the different specifications of the data type have been mentioned right there. So I have my table right here now. Now, to combine, don't forget I have students at a table, I have teachers at the table. But if I want to join different entries from the two tables, I can equally do that. And all I need to do is just to make a few selections and just say, okay, go in here, select this particular table, select this set of entries or columns or attributes in that table, go ahead and select so entries also in another table, then pull it out for me. And that's exactly what I'm going to do shortly now before the time runs out completely. So I have a table called students, as I've established. We also have a table called teachers, as established. And now I want to pull or extract information out from the two tables. The two tables have what we call, one has name, age, and course as different columns. Another one also has name. Another one, I mean, student has name. There's name of student. There is age of student and the course or subject that the student is taking. For teachers table, we have teacher's name. We have the experience, years of experience of the teachers. Then we also have the designation of the teacher. If the teacher, whether the teacher is, for instance, maybe the teacher is a doctor, or the teacher is a professor, or the teacher is a graduate assistant, or what have you. Let me just show you what each of those two tables contains. Then you will see, then I'll now quickly extract something out from the two tables separately and it will report it in a single table apart from the two tables. So let's see what table teachers contain. Run this for me. This is a table called teachers. It has ID. Most of the time you are silent about it because it's auto increasing. So name, experience, designation, this is for teachers. Okay, let's see the table for students. Where are you? Students, I just change this here. Yep. So for students, I have ID, name, age, course. The other one has name, what is it called again? It has experience for the teacher and it has designation. For student, it has name, age, course. Now, what I want to do is I want to pull out information from the two tables by using an SQL command called join. And what I want to do is just to tell SQL that, okay, go into a table called students. I'm specifying that go straight away to a name. That is why I put the name here. And I put X dot. This X dot is standing for students. I will explain it later on because I have requested that the name of the table called student should be shortened to X as an alias. We have something we call alias in SQL. So meaning that another way you want to call this one like a nickname. So the nickname of a table called student, let the nickname be X. The nickname of a table called teachers, let the nickname be T. So I have specified that go into X dot name, meaning that the name column in X table in this case is student table. Go into age column in student table, also go into experience column in teachers table, also go into designation column in teachers table. You can see two different columns from two different tables. I want to pull both of them out in a single report, and I want it to return that report to me directly like that. So after writing that, and I went further to say, okay, from students, consider students table as X. This is where I'm now defining to SQL what I mean by X dot here. That S means student. Oh, it you understand? Oh, you mean table student. All right. Then the T here now means table teachers. Oh, it understood because I have defined it here. Now, the point of connection, which is the point of join, you can now see join students and teachers on this another special SQL command called on. This is where you specify where the connection should be. Where am I connecting from? I'm connecting from their two different primary keys, which is ID. The two primary keys in both tables are the IDs, and that is where I'm joining on. So here I'm joining students.id and teachers.id, and straight away, let's see what is going to pull out for us. Okay. Yeah. So I have a table return now, giving me the name of the student, the age of the student, then the corresponding teacher that has same ID number one with student that has ID number one. The experience of that teacher is coming here, and the designation of that teacher is coming here. And same thing goes for the next one. Uh, for Mary having age 22, then the corresponding teacher, the experience of that teacher is 17, and that teacher is a professor. So while is it pulling out just three for me, if we check the table called students, what do we have in that table? We have up to how many entries? Okay, for the table called student, we have up to 1, 2 to 9. Okay, let's see the table called teachers. How many entries do we have? Teachers, come here. Okay, we have 3. Okay, if one table has 3, then the final output you ought to give me should be at least the list of one of the tables, right? One is 3, one is more than 3. Why was it giving me something less than 3? It was because in the second table called student table, there is no ID number for 3. There is ID number 1, 2, 3 in teachers table, but in student table, there is nothing like ID number 3. That is why the final output for that join command is just 2. So you can see the ID number here is 1, 2, 4, 5 up to 9. There is no ID number 3. That is why it could only pull out 2 for me, ID number 1 and 2, because we are joining on ID of the 2 table, and that is why the final output is showing just 2, ID 1 and 2. Yep, I will need to switch to the next call now for another section for another set of people. Bear with us, we will need to continue from here next session. Is there any quick question or anything you want to quickly ask? And if there is none, you can go ahead and watch the recorded sections we've had so far. We are having more than 30 already, because we've been on this for more than 30 weeks since last year, and we've been having incremental and accumulated developments in the whole process. So please do well to take advantage of those recordings, and if there's any question, you can put it on this chat or you bring it during the next session. You've got to increase your capability and block all workforce analytics adoption gap wherever it is happening, or wherever you're experiencing it, either at work or in any place, as it were. See you all next session. We'll have to draw the curtain at this point if there is no question. Thank you and have a wonderful week. Yes, by the way, happy Father's Day to everybody, and everybody having one father or the other in their lives. Thank you. See you again next class. Bye for now.